Hello, welcome. Let's try to solve another Leetcode problem 2360, longest cycle in a graph. So we are given a directed graph, n nodes numbered from 0 to n minus 1. So where each node has at most one outgoing edges. So this is a very important information. So from the first sentence, we should know that this is gonna be a tree cycle problem. Yeah, so according to this kind of information, we should know that. So it's going to be a cycle. So the structure going to be a cycle like this. Yeah. So we are given a directed graph. So this is a directed graph with n nodes numbered from 0 to n minus 1, and where each node has at most one outgoing edges. So one node has one outgoing edges and one node has one outgoing edges. It is like that. Maybe there are also some other edges. Maybe it is yeah, like this. So for this node, it has one outgoing edges, and for this node, it has one outgoing edges, because we are not considering about the ingoing edges. So for this node, it has two ingoing edges, but it doesn't matter. We are only considering the outgoing edges. So it may be from some other places. So this is another node, and it's gonna direct it to a cycle. Or maybe there's another cycle, and we don't know what is the what is the length of the cycle. We don't know it. Maybe this length is 4. Yeah, let me just make another drawing, and there's another node. It's gonna direct it to a node inside the cycle. So let's just calculate how many nodes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's gonna be 10 nodes. And how many edges? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it's gonna have 10 edges. Yeah, so the number of edges gonna be equal to the number of nodes. So this kind of a problem, we're gonna call it a tree cycle problem. So it is basically a tree structure, but inside there are gonna be some cycles. So in this example, it has 2 cycles, but we are going to calculate the longest cycle, so it's gonna be 4. Yeah, so let's just continue. So the graph is represented with a given zero-indexed array edges of size n, indicating that there is a directed edge from node I to node edges I. If there's no such outgoing edges from node I, then edges I going to be -1. Now let's just try to understand from here. So we are giving this kind of edges. It means from 0 to 3, they're going to be a directed edge, 0 to 3, and index 1 to 3, and 4, 2 to 4, and this is 2 to 4, and 3 to 2, and 4 to 3. So inside there's a cycle, so we're going to return a 3. Yeah. So now we need to understand how can we solve such kind of problem. So we're going to return the length of the longest cycle in the graph. If no cycle, we're going to return -1. So for such kind of problem, normally we're going to use the topological sort. So the topological sort idea is that, so for example, first of all, we're going to go into check what is the integers for each of the node. So for example, for this one, the integer is 0, and this one integer is also 0, and this one integer is also 0. So we're going to start from the integer which is equal to 0, and then we're going to start the topological sort. So after the topological sort, definitely we can get something. Inside there are going to be some values, maybe so for example, this node, while we are doing the topological sort, so the integer for this node is going to become 0, and the integer for this node is going to become 1. And maybe inside of the integer array, there's some 1s, and some other places there may be some 1s, and we just need to check the cycle. Maybe those 4 1s is a cycle, so the length is going to be 4, and those 3 1s may be a cycle, the length is 3. We just need to return the longest. So this is just the idea. We just need to calculate the integer array. Yeah. Now let's just start this kind of coding. First of all, we are going to check how many nodes. So the number of nodes is going to be equal to the number of edges. So we're going to prepare n going to be equal to the length of the edges, and then we're going to prepare an integer array. So the integer is going to be 0 times n. Now we are going to check all the edges and calculate the integer, and we're going to put the integer which is equal to 0 inside a queue, and we're going to start the topological sort. So we just check it. So for UV in enumerate, let's just enumerate the edges, and we're gonna check the integrate. So for the integrate, some of the edges may be a -1. We just need to check. So if this v value is not equal to -1, so this means this is a valid edge, and we're gonna put it inside of the integrate array. So the integrate with v gonna plus equal to 1. So currently, according to this kind of calculation, definitely we can calculate the integrate. Let's just print out what it is, and let me just return a random number 0 maybe. Yeah, so from here we can check this gonna be the integrate. So this means from the index 2 to 4, the integrate gonna be not equal to 0. Yeah, it means 2, 3, 4, it is not equal to 0. But for 0 and 1, the integrate is 0. Yeah, so this means if the integrate is 0, we're gonna put those nodes inside a queue, and we're gonna start the topological sort. And after the topological sort, we just need to check the cycle. So now let's just start the topological sort. So for the topological sort, so we're gonna prepare a queue. It's gonna be the queue, and inside it's gonna be the node. So for I degree enumerate the integrate array, and we're gonna check this integrate. So if the integrate equal to 0, so we're gonna take the node. So let's just check what is the queue. So the queue gonna be some node. Basically, the node are gonna be 0 and 1. So this is our starting point, and then we're gonna starting from this 0 and 1, starting the topological sort. Yeah. Now let's just use the topological sort to solve the problem. So while q, we're gonna pop out to the node. It's gonna be equal to q dot pop left. Yeah, and we're gonna check the neighbors, and we're gonna check the neighbors, and the neighbor gonna be equal to the edges with this node. Yeah, because this edges is just a representation of the edges of the graph. So for example, this is 3, it means 0 to 3, there is an edge. And currently, if we pop out this node, for example, this node is going to be 0, and we are going to check its neighbor. So what's going to be the neighbor? So the neighbor is going to be the edges with this node. Yeah, so this is going to be the neighbor. And we have to check that the neighbor should not equal to -1. Otherwise, it is not valid. Yeah. So if neighbor not equal to -1, so we can start the topological sort. Yeah, I think we need to check the neighbor basically. We put something inside the queue. So in this example, it's going to be 0. Yeah, maybe we don't need to check even for this neighbor, but let's just for safety, let's just check this neighbor. Yeah, so if neighbor is not equal to -1, so we're gonna check the integrate with this neighbor gonna be equal -1, and we're gonna check the integrate. So if the integrate with this neighbor equal to 0, so we're gonna put it inside the queue. So queue needed to append this neighbor. Yeah. Basically, this kind of calculation is just to make sure all the integrates are gonna become. So for this node 3, the integrate gonna become 1 instead of 3, because for the topological sort we will pop out this 0 and we will pop out this 1, so the integrate will be reduced. So for this node 3, the integrate gonna become 1. Let's just check after the topological sort what gonna be the queue. What gonna be what gonna be the integrate? I think we need to check what gonna be the integrate is important. We don't need to check what is the queue. We just need to check what is the integrate. As you can see, the integrate gonna become 1, 1, 1 instead of before for this node 3, the integer is 3. Now after the topological sort, we pop out this 0 and we pop out this 1. So what left behind is only 3, 2, and 4. Let me just use another color. So it is only 3, 2, and 4. So the integer for 2 is 1, 4 is 1, and 3 is 1. And this is really important for us to calculate for the next step. So the next step, we just need to calculate the longest cycle by using this integer array. Yeah. Now let's just check the cycle. I think up to here everything should be clear. And to make sure everything should be right, we need to check the neighbor, because this is just a neighbor, and we're gonna use this as with this node. Yeah, definitely I believe the neighbor should exist. The neighbor can never become a -1. Maybe it can become, for example, maybe this is a 0 to point it to another node, and I can get a neighbor. Maybe adds with this node, adds 3 maybe, yeah, and this value may be a -1. So if this is a -1, how can I start? How can I use the integers? So I have to check the neighbor should not equal to a -1, because if it equals to -1, it means that this neighbor, basically, yeah. So for this example, if this node 1 at index 1 equal to -1, it means basically for this node 1, it has no outgoing edges, and we cannot continue the topological sort. So I think we need to check the neighbors should not equal to a -1. So if you don't check it, let me just make a comment. Yeah, and let's just check what's going to happen. Maybe by using the examples we cannot see it clearly, but for other examples maybe we can find some intuitions about why we need to use this kind of neighbor. So just for safety, we need to check the neighbor, because if the neighbor equal to -1, it means we don't even need to go for the topological sort. And the integer -1, definitely it will make mistakes. Yeah. Now let's just detect the cycle. Let me just write a function. I will write a cycle. So inside I got to put an array, and this kind of a function is basically to check the longest path inside of the cycle. So I'm gonna give a 0, and finally I'm gonna give a result a 0, and finally I'm gonna return the result, and the return gonna be the cycle of this function, and I'm gonna give integer array maybe. Yeah. So the integer array currently gonna be this array, and I'm gonna use this array to check the cycle. So let me just enumerate all the values. So for iv, enumerate the array, and currently we can use this kind of enumerate this integer array to check the cycle. Let's just prepare some variables. Maybe I'm going to prepare an x. How can I check it? I'm going to prepare x maybe, and a cycle maybe. So the x gonna equal to the index I, because after this kind of cycle, the x gonna equal to I again. Definitely it means it is a cycle. Because currently, if there's a cycle, definitely I can find it. Because after the topological sort, I've already removed all other edges, and what left behind is only cycles. No, I only need to check the cycle, because there's no other edges, no other branches. It is always be cycle. So x gonna equal to I, and the cycle gonna equal to 0, and this result gonna be gonna check the longest cycle. So we're gonna use while check. So while this is true, so the cycle gonna plus equal to 1, and let's just check the edges. So the x gonna equal to the edges x, so we're gonna continue to check the cycle. Yeah, because this array is basically a cycle, so we're gonna use it. Maybe I will use some examples to explain it. Maybe this is a good example, but I'll explain it later about how to check the cycle. So definitely we need to check if this is our current x, from the beginning this x equal to I, but now we are going to check if this x equal to I. This means definitely we found a cycle, so we're gonna record the final result. It's gonna be the maximum with result and this is cycle, and we're gonna break it. Because if we find a cycle, we don't need to check for the while loop. We're gonna break the while loop and we're gonna check for the next step. Yeah. So before we check that, we need also to get the integrate. And basically it is this array. So this array with the value x should minus 1, because currently this degree gonna equal to 1, and if we go through the values, we're gonna minus 1. Now the array gonna become yeah. So let's just use maybe this example to check. So we're gonna enumerate this kind of integer array. So we're gonna starting from here. So this gonna be the index 2, and x gonna equal to 2, and the value gonna be 1. Basically, I think we don't even need to use this kind of a value. Yeah, but definitely we need to use the index. Yeah, because x gonna equal to this index. And now what gonna be the edges of 2? And let's just check here. So the edges of 2 gonna equal to 4, and edges of 4 gonna be connected to 3, and edges of 3 gonna be connected to 2 again. This means if this x equal to 2 from the beginning, so we're gonna record the result. It's gonna be equal to 3 basically. Now, but for the integers, after that, the integer gonna become 0. It means if we find this is a cycle, we don't need to check all others, because we've already finished checking for the cycle. Yeah, I think that's all for it, and it is a lot of coding, but I think everything should be clear about how to calculate it. Yeah, let me just run it to check if there's something wrong with it. Yeah, it means I definitely got a infinite loop from here. So x gonna equal to edges x, and if this x equal to I will break. Yeah, but currently I cannot break it. Yeah, let me just comment the cycle checking areas and print out what's gonna be the x. Yeah, as we can see from here, the x gonna be like 0, 1, 2, 3, and 4. But actually, we don't need to check 0 and 1. Yeah, because for our q, we only need to check from the index. Let me just print out the integer. Yeah, because we only need to check for the integer. Let's just check this integer array. Yeah, as we can see, the integer array is 0, 0, 1, 1, 1, but our index is 0, 1, 2, 3, 4. But we don't need to check the 0, because it doesn't matter. We only need to check which is the value equal to 1, because this is a cycle. 0 is not the cycle, because after finishing the topological sort, definitely it's going to become 0, and we just need to remove that. So we're going to only check 1. Yeah. So from here, this means we're going to only check the value which is equal to 1. Yeah. So let's just check it from here, maybe. So if v equal to 1, so we're gonna start the cycle checking, because if it is 0, we don't need to check that. Now let me just run it to check if it is okay. We paused for some testing cases. The testing cases 1 is okay. It means that detect the cycle, and but for the testing case 2, it is not okay. So my output is 0, but the final output should be -1. Yeah, because according to the question, if we didn't find a cycle, we're going to return a -1. This means my result cannot be 0, it must be a -1, because this is what is described in the description. So we have to follow the description. Now let me just run it. Now as you can see, it works, and let me just delete the print and submit it to check if it can pass for all testing cases. As you can see, it passed for all testing cases, and it's pretty fast. And this kind of problem, we're going to call it a tree cycle, and the method is topological sort. So the idea is that, according to the question, we're going to just remove the branches and we just leave the cycle, and we're going to check the longest cycle. So this is not so difficult. This is just topological sort template, and we need to know about it. So from here, as I mentioned, we should check this -1, otherwise it's going to have mistakes. So if you don't believe it, let me just run it and submit it to prove it. Yeah, I believe it's going to make mistakes, definitely. Yeah, because this is not the right way of solving the problem. We have to check the neighbor gonna not equal to -1. It means we're gonna continue the topological sort. Yeah, now let me just submit it again. Yeah, and another thing about it, I think, is about the cycle detection. So there are many ways to detect a cycle. You can use the DFS, but for this problem, we can just iteratively use a while loop to check. Because definitely we're gonna use this index to check, and if there's a cycle, according to the edges, according to the information what we're giving, we directly can use this x equal to edges x, and it will continue until we find this x equal to I. It means we've already found a cycle. We just need to record the maximum cycle, and we can break the while loop immediately, and we can check the next cycle. Maybe the next one is longer. I think that's all for it. Thank you for watching. See you next time.